Hi guys, welcome to Sign Up. In this session, we are discussing about the amplitude modulation. Okay, so amplitude modulation. So what is meant by modulation and why we use the modulation and what is the need of the modulation? Okay, so generally the voice signals is in the range of 30 Hz to 20 Hz to 20 kHz. Okay, means the voice signals appear in the low frequency ranges. When you transmit through the channel, the signals are easily affected by the noise. So to overcome this noise, we use the modulation. Means we convey a low frequency signal into a high frequency signal or overlapping a low frequency signal on high frequency signal. Okay, means modulation means so modulation means we overlap a low frequency signal on high frequency signal. So here the high frequency signal is also known as the carrier signal. So means we overlap a message signal on a carrier signal is called modulation. And the exact definition of the modulation is the characteristics of carrier varies with respect to amplitude of message signal. So the exact definition of the modulation is the characteristics of the carrier signal varies with respect to the amplitude of the message signal. Here we consider the characteristics of the carrier signal, means every signal contains the three characteristics. One is amplitude, and second one is frequency, and third one is phase. Okay, so in place of the characteristics, we use the one of the characteristics. For example, if the amplitude of the carrier signal varies with respect to the amplitude of the message signal, then it is called amplitude modulation. If the frequency of the carrier signal varies with respect to the amplitude of the message signal, then it is called frequency modulation. And if the phase of the characteristics of the phase of the carrier varies with respect to the amplitude of the message signal, then it is called phase modulation. Okay, so these are the different types of analog modulation. And next one, what is the need of modulation? So need for modulation. Okay, first one, to reduce the noise, because low frequency signals are easily affected by the noise. So to overcome the noise effect, the low frequency signals are overlapped on the high frequency signals. And next one, it is used for the far distance communication. And third one is we use the multiplexing, means we transmit the number of channels within a single channel. So the technique is called as multiplexing technique. So by using the multiplexing, the low frequency signals are easily overlapped with each other. So by using the different carrier frequencies at high frequencies, we use also multiplexing technique. And last one is to reduce the height of antenna. Okay, so last point is to reduce the height of the antenna. For example, if you consider the height of the antenna is related with the wavelength. For example, if you consider the half-wave dipole antenna, the height of the antenna h is equal to related to lambda by 2. So half-wave dipole antenna, the height of the antenna is equal to lambda by 2. Here lambda is equal to, lambda is wavelength. And the wavelength is related to frequency, nu is equal to c by lambda. Here nu is equal to frequency and lambda is wavelength. Therefore, lambda is equal to c by nu. Here c is time constant, light constant. Its value is 3 into 10 power 8 meter per second. Okay, so therefore the only alternative is by changing the frequency. In general, for example, if you consider the audio frequency range from 20 Hz to 20 kHz, 20 to 20 kHz, for example, if you consider a human being audio frequency is a range of 3000 Hz, then the lambda is equal to 3 into 10 power 8 meter per second by 3000. So 3, it gets cancelled in 1000 times. So therefore, lambda is equal to 10 power 5 meters. Therefore, h is equal to lambda by 2. So is equal to 10 power 5 meters by 2 is equal to approximately 50,000 meters. It's equal to 50 kilometers. Means the height of the antenna must be designed to a 50 kilometers height of the antenna. It's not impossible to design. So the only alternative way is here C is the time constant. It does not change. So the only way is to change the frequency. Means the low frequency 3000 Hz is replaced with the, for example, if you 3 megahertz, then 3 megahertz into, so 3 into 10 power 6. So 10 power 6 gets into the 10 power 8 by 2 times and 3 cancel each other. Therefore, lambda is equal to 100 meters. Therefore, height of the antenna h is equal to lambda by 2 is equal to only 50 meters. So, by using the modulation, we reduce the height of the antenna. So, this is the need of the modulation techniques. Okay, and next one, now we are discussing about the amplitude modulation and the standard amplitude modulation. The standard AM equation S of t can be written as S of t is equal to AC into 1 plus Ka M of t cos 2 pi Fct. Okay, here M of t indicates the message signal, whereas M of t can be written as AM cos 2 pi Fmt. Here AM indicates the amplitude of the message signal and FM indicates the frequency of the message signal. Here AC indicates the amplitude of the carrier signal and FC indicates the frequency of the carrier signal. Therefore, S of t equal to, by multiplying each other, so AC cos 2 pi Fct plus AC Ka M of t cos 2 pi Fct. Therefore, AC cos 2 pi Fct plus AC Ka, so M of t, in place of M of t substitute AM cos 2 pi Fmt into cos 2 pi Fct. So therefore, AC cos 2 pi Fct plus the second term is in the form of cos A cos B. Therefore, AC Ka AM by 2 cos A plus B Fc plus Fmt plus cos 2 pi Fc minus Fmt. Means the first term indicates the carrier term and second one indicates the upper sideband and third term indicates the lower sideband. Means the conventional amplitude modulation contains the namely three terms. First one is carrier and second one is upper sideband and third one is lower sideband. Okay. Therefore, by using the four-way transform, we apply the four-way transform. So this is the time notation of representation of amplitude modulation. Now you consider the four-way transform. Therefore, S of f means frequency representation of the amplitude modulation. S of f is equal to, so AC cos 2 pi Fct. Okay. So by using the multiplication property of four-way transform, we get S of t is equal to AC into del of f minus fc plus del of f plus fc. So AC into cos 2 pi fct by using the multiplication property del of f minus fc plus f plus fc plus Ka into Am. So Ka into Am is indicates as the modulation index mu. Therefore, AC mu by 2, AC mu by 2, M of f minus fc plus m of f plus fc. Okay, so is equal to AC by 2, AC mu by 4. Okay, so by using these two equations, can you draw the, now we draw the spectrum of amplitude modulation. So it contains three terms. First one is fc, fc plus fm, and fc minus fm, and similarly on negative side minus fc minus fc minus fm minus fc minus fm. Okay, so fc means at the carrier frequency the term contains AC cos 2 pi fct. Therefore, the amplitude of the carrier is AC. Therefore, it's split into two types, AC by 2 and negative side AC by 2. And similarly, at fc plus fm, its value is AC mu by 4. AC mu by 4. And similarly, on negative side, AC mu by 4 and AC mu by 4. So this is the spectrum of the amplitude modulation. Means in amplitude modulation, it contains three terms, carrier, upper sideband and lower sideband. So the carrier contains the higher power and both upper sideband and lower sideband contains the equal power. Okay, so this is all about the amplitude modulation in time domain and frequency domain representation. I hope all of you understand this topic. We will meet in the next session.